Okay, so in the previous classes we talked all about the different types of errors. So we are not going to talk here about the systematic or random errors, the definition based, but yes, we will mainly focus on numerical based problems that are based on the errors. So particularly I will describe the errors what we are going to require. One, mean absolute error, right? Mean absolute error. Then comes relative error. We also call this as fractional error. And finally percentage error. So let's take an example to understand all these types of errors. So let us say I measured the length of pen, and the different lengths that I have got are 9 centimeter, 9.1 centimeter, 8.9 centimeter, 8.8 centimeter. Okay, only 4 readings let's take, and it is given that actual length, that means the real length that is marked is, let us take 9 centimeter. Now here we are required to find out mean absolute error. Okay, all these three things we will find: mean absolute error, relative error, and percentage errors in each observations. If we understand this one, then it is very easy to do any questions based on errors. So first, let me write all the lengths that I have measured: 9 centimeter, 9.1 centimeter, 8.9 centimeter, and 8.8 centimeter. Actual length is 9 centimeter. So we can conclude error in the measurement of first observation is 0. Right? Here I am writing the errors. Error in the measurement of second is 0.1. Error in the measurement of third is 0.1. Right? Error is always a positive quantity. In the fourth measurement, error is 0.2. So you can observe what error I am writing here. The absolute errors. Right? Errors are always absolute. You will never find negative errors. Now, what is mean absolute error? Actual length. See, how did I get actual length? Even if this actual length is not given, you can determine actual length. So how can we determine actual length? Just take the mean of all of these values. So if you take the mean of 9, 9.1, 8.9 and 8.8. So if I sum up and I divide it by 4, you can see you are getting 8.95. Okay, so I'll make a little change so that we get 9 only. Let us also take this reading to be 9. Right? Now you can see if you take the mean, you will get 9 only. If this actual length is not given and the readings were what we had previously written, then you are required to take its mean. That means you have to take 8.95, not the 9. Or they would have given you 8.95, not 9. Okay, yes, but in this case, we find the mean. Let us say each reading I indicate by xi, right? That means x1, x2, x3, x4. So what are x1, x2, x3, x4? That means what is this xi? This is my reading. That means my measurement or measured value. And this is the mean value. 9 what we have here, that is the mean value. And what is absolute error? So in 9 centimeter, you can see, first I'll make this as 9. 9 centimeter, how did I find the error? I took the absolute value of x1 minus x mean, right? Or you can take, you can also write it as, it doesn't make any difference, x mean minus x1. This is x mean minus x2. This is x mean minus x3. This is x mean minus x4. So these are absolute errors. What do we, how do we read it? This is absolute error in first measurement, right? This is representing the number of measurement. So first measurement, what is the absolute value? This one. This is the absolute value in second measurement. Absolute value in second measurement and so on. So basically, let us say x1, x2, x3 and so on till xn are the measurements, and to find the actual value or that value which is very promising, means very much near to accurate value, we take the mean, and that is indicated by summation xi by n. Okay, once we find mean, then we can find out the error in the measurement of first. What will be that? Mean minus that value, and then error in the measurement of second, mean minus second value, and so on. So at the last I will get mean minus xn. Okay, now talking about mean absolute error. So as the name itself suggests, mean absolute error means we are going to take the mean of all the absolute values. So you have to of course add all these absolute values and you have to divide it by n to get the mean absolute error. Now what is relative and percentage error? That we have already had idea in the previous lecture. So let us suppose in the measurement of x there is an error. So x is represented as x plus minus delta x, then relative or fractional error, that is delta x by x. Whereas percentage error, what we do to calculate, we just do delta x by x into 100%. Okay, these were the basics of errors. So now we will see the propagation of errors. Propagation of errors. So let us suppose I measure the length of a pen and the error I got in its measurement is delta L1. I measure the length of another pen. Let us say it is quite big. The error here I got is L2 plus minus, or let us say B plus minus delta B, the reading. So error here I got is delta B. Now if I combine both of them, that means if I place it like this and then like this, then what error I'll get? That means here I can see the objects are combined. So here let us suppose I was getting 2% error, here I was getting 1% here. So total if I just add them, then just remember errors are added up. So there could be two operations. One, either we could add or subtract the quantities. So while we add or subtract, errors are added up, right? So when these lengths are combined, so I can write L plus B plus minus their errors, delta L plus delta B. So you can see if I have added both the quantities, then their errors are added up as well. The second operation possible could be multiplication or division operation. So while we multiply or divide two quantities, let us suppose this is L, this is B. Let us suppose I do L by B. Then in this case, I can write L by B as L by B by considering this, and to get the error, we have to follow a different method here. When the quantities are multiplied or divided, then their relative errors are added up. Their relative errors are added up. Look at one more example to clear this as well. That also a basic example. Let us say I measured the length of a rectangle as 10 plus minus 0.1 and breadth I measured it as 5 plus minus 0.2. Then here let us find the perimeter and the area. So to find perimeter, we'll just do 2 times L plus B. So here we are seeing there is addition operation. So their errors will be just added up. So it will be 2 times L plus B. I will add their main values. So 15, and then I will add the errors. So it will be 0.3. So it will be 30 plus minus 0.3. Is this the one which you are getting? Let us see the complete details to get the exact right answer. Okay, this is the perimeter that we have got. Now, what we have, L is, let's say, 10 plus minus 0.1, B is 5 plus minus 0.2. Then, perimeter, how I will write? Perimeter will be P plus minus delta P, right? So, let us first find P. P will be 2 into L plus B. So, that will be 2 into 10 plus 5, that will be 30. So, okay, I have got this P. Now, let us find delta P. What is this delta P? It is the error in the calculation of perimeters. So, let us find delta P. Delta P will be delta L plus delta B. And I should also multiply this by 2, because if I, let us suppose, add A to B, then I will add errors in A and error in B. If I will add A to A only, then I should also add error in A and error in B. So, we should not forget this factor while finding the errors. So, the error in length is 0.1, error in breadth is 0.2 into 2, that will be 0.3 into 2, that will be 0.6. So, perimeter will be 30 plus minus 0.6. So, this gave us the idea how to find perimeter. Okay, now we will compute the area. Let us find out the area with respect to errors into consideration. Okay, the length here that is given is 10 plus minus 0.1, breadth is 5 plus minus 0.2, area we know it is length into B. So, area how we will write? A plus minus delta A. So, A we already know, it is L into B. So, this is L, this is L, this is B. So, it will be 50. Okay, we got this as 50. Plus minus we will find error in A. So, relative error in A is relative error in L plus relative error in B, right? Because they are multiplied, relative errors will be added up. So, here again we have to observe, we have to find change in area, that means the error in A. So, we have to take this area and multiply here. So, this will give us the error in area as what is A we already found. Let us put the value of delta L and L. So, 0.1 by 10 plus 0.2 by 5. So, if we compute, this will come out to be 50 times 0.01 plus 0.04, and that will be 50 times 0.05. So, that will be 2.5. So, yes, area will come out to be 50 plus minus 2.5 meters square. So, let us do this question based on error analysis. Okay, so the question here is, if the error in measuring a quantity x is 2%, that means delta x by x is given as 2%. We have to compute the percentage error in x squared. So, percentage error in x squared, if we observe x squared, let us say z is equal to x squared. So, we have to find percentage error in z basically. So, percentage error in z will be equal to 2 times the percentage error in x, right? Because x square you can write it as x into x. So, here you can see the quantities are multiplied. So, you just need to work accordingly, and it is 2 times of 2%, right? Because delta x by x into 100 is 2. So, this will be 4%. Similarly, we can find out for this. So, it will be 2 to power 5%, that is 32%. Root x, if you take root x, let's take z as root x. In this case, percentage error in z will be half of percentage error in x, right? So, that will be half of 2. So, it will be 1%. So, how I am finding the percentage error is in this thing? I'll give the expression at last. So let us say we have a quantity z is equal to a to power m, b to power n divided by c to power p. I want to find the percentage error in z. So this is the percentage error in z. So it will be equal to the percentage errors in A, percentage errors in B, and percentage errors in C. So we will add these percentage errors, right? Because the quantities are multiplied and divided. We just add the relative errors and multiply 100, you get the percentage errors. But you can see here the powers of A is m. So we will bring the factor m to the front, n we will bring here, and p we will bring here, right? Because the rule is very simple. A to the power m, it just means that I can write a m number of times. So if you just add delta a by a plus delta a by a m times, it is nothing but m times delta a by a. Alright. So yes, we complete the error analysis and complete things related to the propagation of errors. In the next class, we will talk about certain numericals based on the complete units and measurement. Okay, see you all in the next class. And if you all have not watched all the previous videos of units and measurement, I recommend you all guys to watch it. You will find that link in the description box, and then it will be very good for you all to attempt the next session, that is lecture number 5. Okay.